So good afternoon. You already know everything from this slide. My name is Aleksandra Chirkina, and recommender systems for personalized financial advice is the topic today. And this is another cover slide, but this is just to show off the logos here. So I'm a data scientist at InCube, and we are a fintech company based in Zurich, Switzerland. And here you can see another logo of Bank J. Safra Sarasin. They are a private international bank focusing in sustainable investment. And we implemented this project together. Now, recommender systems, I'm not really sure if they even need any introduction. Like, this is what I saw on Amazon when shopping for a book on recommender systems. So I already started receiving recommendations even before buying anything. Now, this is what I see on Netflix. It recommends me new TV shows and can even explain the basis for the recommendation. So which TV show from my history served as an explanation for these further suggested TV shows. However, this picture here is not that common. So here we can see a rather minimalistic mock-up of a potential web page with personalized investment ideas in an e-banking system of a theoretical bank. So as you bought shares of Facebook, you might be interested in these further companies. And I'm wondering why not, because these systems has proven themselves to be efficient in other applications such as retail and online shopping and entertainment. They have helped these companies to increase usages of their system as well as revenue by huge margins. And additionally, for a bank, such a system would save time and effort of relationship managers because it would automatically suggest new investment ideas. And of course, it will look bank to appear modern, which is good for younger customers. Luckily, this was exactly the line of thought of management of Bank J. Safra Sarasin. That's why they decided to implement this AIRS project, which stands for Artificial Intelligent Recommender System. And InCube was chosen as a partner for implementation of this project. This is the outline of my talk today. So we will have a brief introduction into recommender system in case someone doesn't know the technical details. We will see at the inputs and outputs of the system. Then we will have a closer look at the core algorithm inside, which is collaborative filtering. Then I will cover area-specific challenges that are specific for finance. We will also consider how such a system can react to explicit feedback given by the clients. And lastly, we will see how the recommendations are integrated into core banking system. So this is how an input for a recommender system usually looks like. We have a set of users and set of items that they can purchase, or in this example, we have movies. And what unites them together is ratings metrics. So a user has watched a movie before and has maybe given it a 5-star rating, or maybe didn't. So we only know the fact that they watched this movie. And the goal of a recommender system is to predict all the missing ratings as well as implicit ratings in this matrix. So if a user had known about this movie and if they had watched it, what rating would they give to this movie? This is a potential output of a recommender system. So for each user and each movie pair, there is a predicted rating. And these predicted ratings can be used to produce recommendations. Say we need top 3, so 3 recommendations per client. We simply rank the movies according to the predicted rating and take top 3 of them. So easy. But how exactly does this recommender system predict the missing ratings in this matrix? So we will have a look at this now. Suppose this is all potential movies that a recommender system can select to recommend to a user. And when the recommender knows as much as this amount of information, which is basically nothing, it could as well choose randomly. However, when we start learning features about the movies, so for instance, now we know which movies belong to romance category and which to action, the recommender can do a better job. And basically, the more features we learn, the better predictions a recommender can do. So further we divided into realist and escapist and drama comedy, and now it's fairly easy to make a recommendation for someone who has already watched some movies before. However, in a real system, these features either not come as granted, or we have so many of them that we are just lost. We don't know which ones to select and which ones would serve as potentially useful for a recommender system. So in best case scenario, the recommender would learn these features automatically. And this can actually be done by employing matrix factorization-based collaborative filtering. Matrix factorization means that this sparse rating matrix is decomposed into, well, approximately decomposed into a product of two dense matrices, users and items latent features. So latent features is a shared dimension for both matrices. And for users, it kind of indicates the preferences of the users. And for items, it indicates their characteristics. Unfortunately, as I've said, these features are latent. That means that the system gives us values for these features, but it doesn't really show what this feature is. So they are not easily interpretable. Interpretations are still possible, but they require heavy human intervention. And honestly, they are not necessary in this at this stage. This matrix factorization collaborative filtering is a popular algorithm. It is used in many systems now. It produces accurate results. And we decided to employ it for our use case as well. However, we had to heavily adapt it for challenges in finance. Well, you might wonder why I put so much emphasis on challenges in finance specifically, because after all, it's just another application area, isn't it? Well, not quite, because financial data is substantially different to the data where recommender systems are usually applied to. This is how your average recommender system might look like for a retail industry. So there is a collaborative filtering and maybe some explicit feedback loop involved. However, this is the system that we ended up designing to adapt it to investment ideas use case. We will briefly visit every component of this picture, and we will start with the collaborative filtering, which is still the core algorithm, but we had to adapt it. So this is what you would expect to see as an input for investment ideas recommender system. So we have users and items, and the only difference now is that they are not movies, but shares of companies. And we again have ratings. However, this is not the case. And what we rather see is this, because clients don't normally give 5-star rating to the investments that they have made in the past. So the only thing that we know is that a client has held shares of a company at some point in the past. Just based on this information, we cannot really deduce whether they were satisfied with the investment that they made at all. Maybe they held this product but were unhappy with it. And additionally, we cannot really be sure about the exact meaning of these missing ratings. Did the client not invest into this product because they honestly didn't like this idea, or maybe they were simply unaware of it, and maybe if they knew, they would invest into it? So for training of the model on such a data, we still have to come up with some numerical values, how to substitute the sticks. And this is one big question. How do we do that? Do we treat them all equally? So we simply plug in once there, or maybe we count holding period in months. So assuming that the longer a client has held a product, maybe the more satisfied they are. Or maybe we measure trading activity within this holding period. So assuming that the more actively a client has traded a security within the holding period, the more satisfied they are. There is endless number of possible approaches, and each of these possible approaches can be argued to be better or worse. However, before actually using this approach for training the system, it is impossible to verify whether the approach is plausible or not. So in order to select the best one, we had to try out several, train the model, measure its performance, and only then select the best one. And after extensive experimenting, we have confirmed that trading activity is in fact the best approach. So this is the one that we ended up using in the productive system. However, we didn't quite take exactly these numbers. So what we did, we treated these numbers as confidence. So we still use 0 and 1, so 0 means dissatisfied, 1 means satisfied, but we use these numbers to indicate how confident we are that the client is satisfied with the investment. So here in the top left corner, we see high trading activity. So we are really sure that there must be a 1 there. And where we see low trading activity, we are not really sure if it's 1 or maybe it should have been a 0. Additionally, with this approach, it's very easy to take missing ratings into account. So, okay, we impute zeros there, but we assign confidence level to be a really low value. And you will see now how it helps. So this is actually the loss function that we minimized for this task. So it might look familiar to you because this is a mean square loss. This is a loss that is usually minimized when using matrix factorization approach. But as you see, we plugged in confidence weights here. So thus, different cells of the matrix contribute differently to this loss function. The cells with very low confidence weight contribute little, so the algorithm is given freedom to impute basically any number it wants. But these cells with high confidence contribute a lot to the loss. This algorithm is accurate, and as it turned out in the end that it produces very good results. However, it doesn't grant explanations on the way. And explanations are really important for financial use case because potentially clients could bear substantial financial losses if they followed our advice. So their trust in the system should be high, and explanations help increasing this trust. Right, so in order to still find them, we had to employ a complementary model. Explanations in collaborative filtering use case can only come in a form, as you bought product A, you might like product B. And this is exactly the form of explanations that we aim for. And this is the complementary model that we employed to find out these explanations. And here you can see a reference to the paper which described this model. So suppose the goal is to produce recommendation for this client highlighted in blue. And what the system does, it tries to find this block structure in the matrix. These blocks combine user item pairs that belong to the same thematic category. So here we can assume that this yellow block might unify music items and music enthusiasts, and this blue block might be about technology and, well, technology enthusiasts. And when we see this structure, it becomes really easy to produce an explanation. So these earphones are recommended to this user because they have bought radio and a CD disc before, and well, users who bought this also were interested in earphones. So that's how we produce explanations. And now I have to confess something that what I told you before was not entirely true. So the ratings metrics that we saw before, as an example for financial use case, had shares of specific companies as columns. However, in the final system that we produced, we used something else, which is product bins as columns. I will first show you how we produced them and then explain why. So as a raw input for the recommender, we still have individual assets such as shares of these companies. However, first we create asset categories. So for that, we need to select a set of features for the assets that we are going to use to produce this category. So in this example, it was country, asset type, currency, and market and risk level. So obviously, assets that share the same values for these features go into the same category. And then we construct ratings matrix on category level and not on individual assets level. Now, why do we do this? First of all, it starts issue of cold start for products. Cold start is a known problem for collaborative filtering. So the essence of it is that when a new product is introduced into the system is not able to recommend it until someone buys it. So it can just hang out there without, and no one would ever know about it because the system doesn't recommend it. So this is not the case here. When a new product is introduced into such a system, most probably it would belong to an already existing category, and thus the recommender will be able to pick it up because this category has history of purchases and propose it to some clients. Also, time-varying product features. Now, this is a known issue for financial use case. The issue is that products in finance don't really have constant values of the features in time. So stocks of a company or of a young startup might be a value stock a year ago when they were just starting, but right now when they gained attention and maybe become more successful, it can be a momentum stock. So the essence of the product changes. And by combining products into bins, we solve this issue. That is, we count clients' preferences to the category where product belonged at the moment of purchase and not currently. And in such a way, we can measure clients' affinity to the characteristics of the products and not specific companies, which is more important for us. Of course, it reduces dimensionality as well as sparsity, and it is known that collaborative filtering systems work better with less dimensions and less sparsity. And on the business side, product binning allows us to easily introduce business logic on top of the AI and can even help improve it. And in order to understand how it can do it, we need to visit this other side of the pipeline, which is asset selection. So the collaborative filtering trains on asset categories, and suppose this is the category that the algorithm has come up with. But what we need to do in the end is still to recommend an individual asset, so we need to select something from this category. What we do is that first we select bank-approved assets that currently belong to this category, and then we maybe apply some business filters to this. And in this example, we cannot really recommend anything because the client already holds these products and there is no point in recommending them. Sorry. So what do we do then? The first intention would be to skip this category and move to the next one, but then we would lose some added value of the AI recommender that we have designed. So what we do instead is that we expand this category by dropping one of the features. So here it is risk level, and then we have more available assets to recommend, and maybe this time we are able to come up with a useful recommendation for this particular client. Right. So what is actually unique about this project is that in the end, this nice, compliant and explainable recommendations actually made their way to the client's e-banking. So the project is live for maybe 1 month by now, and the clients are seeing this recommendation in the e-banking system, and they can rate them. So they can give explicit feedback, and of course we don't want to miss such an opportunity to collect this feedback and improve the future recommendations for this client. So we will now have a look at the feedback loop and how we implemented it. The feedback is binary, it's simply like or dislike, and yes, of course we want to collect it and use it to improve our model even more. And obviously during the development, we didn't have access to any real feedback because these recommendations didn't make it to the clients yet and so on. So we had to experiment, we had to simulate the feedback and then use our approach that you will see in a second and see if the recommendations change in the way that we expect them to change. So these experiments show that the approach is legit. So that's the approach that we ended up having in the system. And it is the following. So as you might remember, this is the loss function that we want to minimize when doing our matrix factorization. So when we receive explicit feedback, what we do is that we tweak the corresponding member of the loss function. if we receive a negative feedback, we set the weight, the confidence weight, to be maximal possible in this setup. And we set the true rating that the algorithm should aim at predicting to be 0. And thus, the algorithm is forced to also impute 0 for this matrix cell, and thus the corresponding category is pushed back in the ranking list for this client who gave this negative feedback. When we receive positive feedback, we do something similar. We also set confidence weight to be as high as possible, because now we are really confident that clients are satisfied with this category. But we set the true rating also to be high, and then the algorithm must also predict a higher rating, and this category will appear higher in the ranking list, and thus will make more chances to make it in the final recommendation batch for this client. And now we move to probably the most important part of my presentation, because we are all very excited that this recommender system actually made it to the production. And while you might wonder why we are so excited about this, because in the end, a lot of companies already have such systems in place, such as Amazon and Netflix. But when it comes to investment advice, private banks, especially in Switzerland, remain largely conservative. So they are very reluctant to employ any new technology for this. And we could actually implement this project for investment advice. So yes, we are very proud of it. The project consisted of 2 phases. After the first phase, the recommendations were presented to client relationship managers, so not yet to the end clients, for approval. And this is what client relationship managers saw in their system. So we see here a recommendation and then an explanation. I'm not sure if you can see it, but it says, as you bought ABB in the past, you may like this new share at the moment. And it also shows selection path, so all this asset selection pipeline that I showed you, which category was selected, which business filters were applied, and which features were dropped to actually come up with this final recommendation. So for client relationship managers, it is very transparent what actually happened in the algorithm and why it recommends this to the client. And I need to say that the acceptance rate of these recommendations by the relationship managers was quite high. And this was in large part the reason why the project actually made it after the first phase into the second phase, which was already putting it into production and making the recommendations, putting them into the shape when they are ready to be presented to the clients. And in the end, this is what clients ended up seeing. It is just a screenshot. This is an actual screenshot of an e-banking system of Bank G. Safra-Sarasin for one client. And it has a lot of information, but what we are interested in is in this bottom left corner, the investment ideas. So this is exactly what our recommender system produced. And this is how they are shown in the e-banking. Each of them is clickable, so we can click on one of them. And if we do so, we can see some more information about this asset. So the history of a performance indicator, how it did during the last year. And here we can also see some news articles related to this specific investment. And the client is given the chance to rate this idea, whether they like it or not, to help improve the next recommendation batch for them. Okay. Now, just to recap, why do we need a recommender for financial advice? So for us at InCube, and together with Bank G. Safra-Sarasin, it is obvious why. Because first of all, such a system would produce relevant investment ideas with high acceptance probability by using a highly accurate algorithm. Quality control is very easy to impose, so banks are usually very interested in that. They only want to recommend products that they approve, and we can easily do that by this pre-processing and post-processing steps. Of course, it saves time and effort of relationship managers, and as well as automatically gives explanations. It stimulates client engagement because it gives clients the opportunity to react to these recommendations. And of course, it increases the usage of online banking because now when they see these nice recommendations, they would all go there and give their feedback. Okay, thank you for your attention.
Yes. And we have 2 questions.
Okay.
Sorry, 3. The first one, a predicted confidence score with a high value would essentially mean that there is a possibility for some assets inside the category to have an increase in the near future. Is that true?
Can you repeat again?
Okay. A predicted confidence score with a high value would essentially mean that there is a possibility for some assets inside the category to have an increase in the near future. Is that?
Well, it's not really about the performance of the assets. It's more about the client affinity to a specific category, because some clients of the bank, for instance, they are interested in technology companies. And what we do is that we recommend, well, more technology companies to them if they're interested in them, or if we discover in the history that clients who are interested in technology, for instance, they are also interested in sustainable energy, and we see this correlation, so we recommend that as well. So it's not really about predicting the performance, but it's about predicting how clients would like to invest into this specific category. So yeah, we cannot say anything about the future of this company, sorry.
How do you go down to the asset level in order to propose assets to users? So you just propose categories and not individual assets?
The collaborative filtering proposes category, but then we have a whole bunch of business filters. So you have seen an example with the historical holding and current holding. So that means that we don't want to recommend something that the client has held in the recent past, because, well, they know about it already, and as well as something that they already hold, because, yeah, we rely on that they can handle it themselves. But it's just 2 examples, but we actually had a whole stack of these business filters, and we very rarely ended up with more than 1 asset in a category after applying all these filters. So in the end, we recommend 1 asset from a category.
Okay. Is the recommendation based only on product, service, ownership, or some other inputs goes into the model?
So it is based on the history of holdings across the whole client base of the bank. But as you have seen, we use this product binning, and for this we need to know something about the product. So we have a bunch of asset features that we had to use to produce the product categories. So we saw country, currency, I don't remember risk level, but in the end we had like 13 features, I think. Yeah, so this is another input. And of course, we had to have this extensive input from the bank with all the business filters that they wanted to see applied to the recommendations.
That we all, I mean, those are I finished with the questions. Thank you, and here's the certificate for you.
Thank you.
Thank you, Aleksandra.
Thank you.